Hi students, welcome back. So in the previous video we had discussed about the introduction part of the B trees. Now let us take one example. If you see the example, then you can understand what is that B trees means. And here we also discuss the structure of B tree, how the B tree will be look like. Okay, and we'll take some examples also. So let us take one example for B tree. Here some of the values will be there. That values has to be placed in the form of B tree. Okay, here I have taken some values, key values. Okay, so some of the key values I have taken. Now we will construct the B tree. Let's the order is 3. Okay, order is 3. Order is 3 means you are having the in the previous I said every node has at most m children, means the B tree should be m order. Suppose if I take the order of the tree is m, so like that here I had taken order is 3. So here before going to the problem, let us take the points. What are the keys and for that particular order, and what are the how many children will be there for that particular order. Let us see. So maximum number of child should be 3. So order 3 means, okay, order here the order, the number of pointers denoted the order of a tree. So how many pointers that will be there, that denotes the order of the tree. Here the maximum number of children should be 3. If order is 3, the maximum number of children should be 3. And maximum number of keys should be, so in the previous example the maximum number of keys will be obtained as m minus 1. So that is a children minus 1. 3 minus 1 or order minus 1, you get 2. So maximum number of keys are 2. Okay. Now coming to minimum number of children, it's a seal of m by 2 minus 1. So m by 2 minus 1 means seal of m means 3 by 2 minus 1. So seal of 3 by 2 means it should be 1.5 minus 1. So if you mention the seal of 1.5 is nothing but 2. 2 minus 1, you get 1. So minimum number of child should be 1. And coming to minimum number of, here the minimum number of key. Okay, so minimum number of key should be always minus 1. The key should be order minus 1. So maximum means m minus 1. Minimum means m by 2 minus 1. Okay, so and the minimum number of child. So just see the difference here. M minus 1 should be there. So key means minimum means m by 2 minus 1. So minimum number of child is seal of m by 2, only m by 2. It's not minus 1 because the maximum number of child is m, that is the 3, and the minimum number of child is m by 2. Okay, that is 3 by 2. Seal of 3 by 2 means you will get 2. Okay, so maximum number of child is 3, maximum number of keys are 2, minimum number of keys are 1, minimum number of childs are 2. Okay, so this is the points value. Now let us take the problem. So here what they are saying. So first order is 3. So I taken 3 values. So that is the 5, 8, 9 I had taken. Okay, so 5, 8, 9 taken. Here the number of keys value should be k minus 1, means that is 2. So only the 2 key values should be there. So you divide this as a root. Okay, 8 it becomes the root node. Okay, 8 becomes the root node, and 5 will be left child, and 9 will be right child. So the one thing you have to be noted that the root here, the left child should be less than the root and right child should be greater than the root. Okay, so now 8, 5, 8, 9 all are inserts. Now insert. So here 5, 8, 9 inserted. Now insert 20. Okay, insert 20. So 8, 5, and here I inserted 9, 20. Okay, so over. So what is the next number? Insert 30. So now I want to insert 30. Okay, so if I insert 30, where I have to insert? So right side of the root node. So right side of the node means here. So 9, 20, 30. But the key value should be only 2. Okay, the keys, number of keys should be only 2. It should be. So, but here if I insert 30, it becomes 3. Okay, so here the maximum number of keys should be only 2. So now I want to shift the middle value. Middle node has to be shift to the root node to insert 30. So what now? So here now it becomes 8, 20. Okay, so left side will be as usual 5, and 8 right side should be 9. Okay, and 20 right side should be 30. Okay, so here the 20 is also the root node, but 9 is less than the 20. So left side should be always less, and right side should be always more. Okay, so now just note that numbers, how many numbers we are inserted. 5, 8, 9, 20. Okay, 9, 20, 30, 15, 16, 14, 13, 31. So these are all the keys. So up to we already in 13, up to 30 we inserted. So now check. So now the root is consisting of 8, 20 is there. So here it is 5 was there, 9 is there, and then 30 is there. Okay, so now I want to insert 15. So insert 15. So where I will insert 15? So I have to insert the 15 is less than 20. So less than 20 means it should be inserted left side of the 20. Okay, and if 15 is greater than 8, so it should be inserted right side of this 8. Okay, so here I have to be insert. So now the nodes become 8, 20, and here the 5, and here I inserted 9, 15, and here I inserted 30. Okay, so after 15, now insert 16. So this is here the problem again arises. So where I have to insert 16? So in between 8 and 20, you have to insert 16, because 16 is greater than 8 and it should be less than 20. So you have to insert here. But here already the node is full. Okay, if I want to insert 16, here already the node is full. So now shift this 16 into here. Okay, because not 16, 15, because you have to take the middle node. 9, 15, 16. So 15 you have to be shifted to here. Okay, so this node is full, so split node and you shift that node to here. But if you shift that node to here, 8, 15, 20. Okay, so this is the 5, and here it is 9. Okay, here it is 16. Here it is 30. Okay, but it is wrong. Why it is wrong? Because the nodes, the key value should be, key is only 2. The key value is only 2. So only 2 values you have to be stored in each node. Okay, but here you have stored 3. So now what you will do? So you divide again, you split this into, you you take the middle value and shift the value in as a root node. Okay, so now the 15 is the root node, and the left child is 8, right child is 20. Okay, and here it is 5, and here it is 9, and here it is 16, and here it is 30. Okay, so insert it. So next insert 14. So now insert 14. So 14 is, check here, 14 is less than 15. So now come here. Okay, but here 14 is greater than 8. So come to here. So it will, you can occupy this leaf node, because always insert nodes in the leaf nodes. First you insert the nodes in leaf nodes, after that you have to go to the root nodes. Okay, so now after inserting 14, you will get 8, left side it is 5, and right side is 9 comma 14, and here it is 20, left side is 16, and right side is 30. Okay, and now insert 13, number 13. So where we will insert 13? So 13 is less than 15. So obviously you will go to left nodes. So 13 is greater than 8. So come to right node. But here it's already full. This node is already full. So now split the node. Okay. So which value you have to split? The middle node. So 9, 13, 14 is a middle node is 13. Now this 13 becomes the root of 9 and 14. See here. 15. So this is the 8 and here it is 20. So left side it is 5 and right side is the root node is 13 and 13 left should be 9. So less than 13. Right should be greater. So 14. 20 left is 16. 20 right is 30. Okay. Now the last value is 31. Now insert 31. So this ends the tree. So first is 15. Left side is 8. Right side is 20. 8 left side is 5. 8 right side is 13. 13 left side is 9. 13 right side is 14. Left side is 16. 20 right side is 30. Insert 31. Okay. So this is your final B tree. This is how you are going to be insert the values in the tree form. Okay. Now let us see the structure of B tree. So how the structure of B tree. Structure of nodes of B tree. So what are the structure of nodes of B tree? Let us see. So here you are having so this is the block pointer 1. Okay, and it should be record pointer and key pointer. Key block pointer 2, record pointer, key pointer. Okay, block pointer 3. So like that it's going on up to here key m-1, record pointer m-1 and block pointer m. Okay, so this is a structure of node. So this you call it as a block pointers, and here you are having at most m block pointers. So I said it is the order m, means at most m block pointers. And how many keys are there? m-1 keys. Here m-1 keys are there. Okay, this you noted. So the last record is having the m and the block pointer is m, and the at most m block points will be there, and the record pointers are m-1 and the keys are the m-1. Okay, so now coming here. So this block pointer is always, if you take the node in this block pointer, that node is the value is x. The x should be always less than or equal to k1. So if you take this as a root node, okay, k1. So left side x, the whatever the child value that should be there, that is always less than or equal to k1. Means this is the more and the left hand side will be the less. Okay. Now if suppose if you take the right hand side, what is this? So here k1 less than x less than or equal to k2. So x is the value of the child. Okay, so this child, whatever the present in the right hand side, this should be greater than k1. Okay, so this should be, this x value should be greater than k1, and here this x should be less than k2. Okay, when you compare here, it should be less. Okay, if you take this side, okay, this x value should be less. Okay, if you take this side, when compared to k1, it should be greater. When compared to k1, okay, this x will be greater, and when compared to k2, this x should be less. So I had explained in the previous example. So whatever the root node you are taken, left hand should be always less and right hand should be always more. It should be greater than the root node. Okay, so that here it explained, the x should be greater than key value and it should be less than the next key value. And here also in the B3, k2 less than x and less than or equal to k3. So here also the x, the child, whatever the present here, this should be less than the, greater than the key value, greater than this k2 and less than this k3. So this is a structure of B tree. So now let us take one problem. So here I am I'm giving some points, like here the block, suppose the block size is 100 bytes and key size is 5 bytes. Record pointer is 5 bytes and block pointer is 10 bytes. So they had given some values regarding the size of the block and the key and the pointers. Okay, now I have to find the order of B tree. So with the help of this value, I have to find the order of B tree. So here in this structure of node is explaining the order of M. Okay, so now I have to find out the order of B tree for these values. Let us see. So if you check this, put these values here. Okay, the block size here they are saying that this is 100 bytes, and the key size, so whatever the key that is present, key 1, k2, k3, the keys, those key size will be 5 bytes, and the record pointer r1, r2, r3, those are the 5 bytes, and the block pointer bp1, bp2, so in the middle here, okay, those will be 10 bytes. Okay, now let us see solution. The block pointer size is, what is the block pointer size? Block pointer size is 10 bytes. Okay, so how many number of block pointers, how many number of block pointers are there in the structure of B tree? Okay, number of block pointers are M. Okay, so these are the number of block pointers, up to M block pointers you can save. So number of block pointers are M. So if you want the size of the block pointer, so that is 10 M. So block pointer is 10 bytes. So size of the block pointer is 10 M. So now see the formula. So first is the block pointer. If you want the order of the B tree, block pointer and record pointer minus 1 and the key minus 1. So this is the, if you get this block pointer M, okay, we are taking the size of the block pointer M. Okay, so if you know this last value, then you will get the order of the B tree. So this indicates, this M is indicating the order of B tree. So if you know this value, you will know, means what will be the structure, what is the size of that B tree, order of the B tree. Okay, BPM and the key value should be m minus 1 and the record pointer should be m minus 1. So I said if at most m block pointers will be there, those key values is m minus 1 and the record pointers or data pointers or block pointers, whatever you can take, all are the same. Record, block, data, all are the same. That is the m minus 1 and the key values is m minus 1 and the block is m blocks. So that here you have to. So block pointer m means this is the size they are given. So 10m. So this is the 10m. Block pointer size 10m plus record pointer minus 1. So what is the record pointer m minus 1? What is the size of record pointer? 5 plus m minus 1. What is the size of the key pointer? What is the size of the key? 5. Okay, that should be less than or equal to block size. So block size is 100 bytes. 100 bytes. So these values should be less than or equal to block size. Now calculate 10m plus 5m minus 5 plus 5m minus 5 less than or equal to 100 bytes. So now total it is 20m. 20m minus 10 less than or equal to 100 bytes. So if you move to this here, 20m is less than or equal to 110 bytes. Okay. So now move that 20 to that. So m is less than or equal to 110 by 20. So 0, 0 will be cancelled. Now order of B tree is, okay, order of B tree is m is equal to seal of 11 by 2. So what you will get? Seal of 5.5. Okay, so you will get 5. So order of the B tree is 5. Okay, for these values, for this block size, key size, record pointer and block pointer, they are given. So with the help of these, okay, so with the help of these values, we had find the order of B tree. So that will be the 5. Thank you.